Hello and welcome to part 8 of a series in which I am building a Protogen Head. Apologies for the lack of updates the last couple of weeks. I've had a lot of unexpected stuff come up that I had to deal with IRL, but that should be all taken care of now. So I'm hoping to make a lot of progress in the next couple of weeks because I would like to have this done in time for further confusion in January, but we shall see. Apologies, I only have the one camera today because the other tripod is being used for something which I will also go into later. In the last two parts, I designed the schematic and laid out the PCB to use as a test project to validate that I know what I'm doing. And those arrived a few weeks ago. I obviously haven't made a proper update since then because the last part was we bid them. So I got 5. I have 4 of them here, or 3 of them here. One is upstairs because I was using it to measure stuff, and another one here is populated. There were some minor issues on these boards. For one, I had everything on the Matrix Portal's Hub 75 connector shifted over by 1, so oops. Which means that it wouldn't nicely plug into the board. It would be off by 1 pixel, so I had to use some jumper wires to get over to these, but it worked. It worked fine, just some minor issues. This other connector for going to the LED panel was also not centered on the board, but worked well enough for a proof of concept. Everything functionally worked once I fixed the problems with mounting it, so that's awesome. Earlier today, I just placed an order for a new PCB, which has a lot more stuff on it. It's basically the PCB version of what I have sitting here on the desk in front of me. So I'll go into this, explain what has changed, and probably do some post-production showing updated parts of the board. So those are the PCBs. You might also be noticing that I have at least part of the head frame in shot here. Long story short, I've been having some issues with this, but it's functional for now. It arrived 2 weeks ago. The inner portion of the frame here actually kind of broke. The supports for the screens off here, and these little crossbars kind of broke off, so completely broke in 2. I tried gluing it back together. It kind of held, but the front fell off again. The guy I bought it from said he's never seen something like that before. For now, this still works, especially once I get everything physically attached, which I'll go into more detail later. I do have the other part of the head frame, which I painted yesterday. I still need to do a little bit of touch-ups on it, like here and here where I believe it was resting when I was painting the other part. Needs a little bit of touch-up and a little bit more on a couple other places. And then I need to do a nice glossy top coat, which I don't know how well you can tell with this camera and this lighting, but this is like metallic paint. I have a glossy top coat, and I did a little bit of test painting on a scrap piece. So on this piece up here, the top portion here and here, have a glossy top coat on it to make it a little bit smoother and shinier, not just metallic. But I love the way this looks. This is almost exactly what I was hoping for. Hopefully I can do the touch-up and top coat later this week. It's supposed to rain almost all week and not be particularly warm. That also means it's going to be humid, so it's going to be difficult, but I'm going to try. So moving on to the status of the electronics. What I have here is a Frankenstein's monster of prototype boards to have this all hooked up. I have the Matrix Portal over here on a little tiny little prototype board that connects to the side connector, and also apologies if there's any jump cuts because I only have the one camera to work with. But anyway, so the Matrix Portal is on this little tiny board to deal with the side connector. That tiny board goes to 2 little 6-pin ribbon cables to the main board to be able to get access to these pins elsewhere. I've got 2 connectors for the front, the beginning and the end of the LED panels, so it all can go in here or into there. I have a connector here that I'm not using. This would be for where the boop sensor lives, but I am not using the boop sensor right now because once this arrived, it doesn't work through the tinted visor. It just sees the tinted visor, and I tried messing with some of the sensitivity values and I just couldn't get it to work, so I just gave up on it for now. I'll revisit it later, but it's not super important. So, oh well, it's just not populated. I have the clock over here. It's plugged in with the little cable onto the Matrix Portal's I2C port because I'm using almost every single pin. So I need to use these two pins, so it's just going to be wired like that. I am taking the signal off of that and going over to here, and then the other end of that, it goes through to this little I/O board. I'll get more into that in a moment. Also over here is the internal display. This is no longer connected over I2C. I was having no end of problems having this display on I2C. Something just, I think it's this display just causes I2C bus errors randomly, and that just caused so many problems, and then it just stopped updating. Even if it was on its own I2C bus, I was having problems. So I just gave up and moved this over to a SPI bus. So it's by itself on its own SPI bus. The upside of that, there's absolutely no error checking. This is a write-only device now, so I've not really had any problems. Like it's scrolled a little bit, like a little bit of noise got in or something. But that's simple enough. Just reset the thing, or it'll just be scrolled a bit. But it works just fine. I don't have it doing DMA yet, but that should be relatively easy to do because I know what I'm doing for that now. So even without using DMA for this screen, it's still running at 48, 49 frames per second when I'm talking, and it's animating almost every single frame. Obviously this talking animation is not that great. It's just something I threw together, but it gets the job done. You can also see it more clearly here on the LED panels now that I'm zoomed in on it, and you can see that I'm talking. And the microphone is set to incredibly sensitive right now. I will definitely tweak that. It's a very, very primitive form of code doing this detection, but it gets the job done. So that's all that matters. And obviously I need to tweak the animation stuff here because a lot of the back of the screen is actually going to be covered by the frame when it's all put together. So I have to move stuff on the screen, make things smaller. But that's minor. I can do that once it's all fully assembled. This is sufficient for demonstrating. That's this part. I've got the microphone hooked up, obviously. That's just plugged into the Matrix Portal. I actually goofed on the circuit board for the microphone, so I'll have to do some bodge wires to fix it, but it'll still work. And lastly, what I have on here is this little I/O board, which has a GPIO breakout on I2C, and a capacitive touch driver on I2C. And that's going to be the really interesting one. I have ideas for how I want to use it. I don't want to go into it until I actually try, but it's really cool. I have 4 buttons over here. Again, you can't really see anything because you can't see the screen. So you can see that it's on the normal status display there. The buttons work. The buttons work quite well. I have options to set stuff up. It also has support for full screen animations now. The animation I used to use is available to be selected from the menu. As you can see, that animation is now going on the screen. The way I have it set up is you pick a file and then you pick an animation type. So I could use whatever file that's the appropriate size that I have on there for this animation. This particular animation goes continuously until you hit the back button to exit out of it. The other possible animation is, or one of the other animations that is set up is this one. It just slowly scrolls the image in from the top of the screen, lets it stay there for a few seconds, and scrolls it back out, and that automatically goes back to the normal face. But you can also cancel it by hitting the back button once you're already on the idle screen. I had to back out of the menu first to get to there. And then there's also the ability to just do a static image. Yeah, this is a static image, and this is the image it uses during boot and other operations, but you can obviously select it. But you can use any of those animations for any of the images, so I can have that slide if I wanted to. Also in the menu, there are options for managing this internal screen. You can adjust the frame skip. By default, I think I have it set to 4, so when I'm talking, it's still running at about 70 frames per second instead of the 48 when it was set to 0. You can adjust which color it keys off of for the internal mirror. I have it set to red. You can adjust the intensity of the red. You can also set it to not do any filtering if you are using a full color screen. Other stuff in the menu, not really. Now the fun part that I was talking about, and this is going to be incredibly difficult to demonstrate without moving the camera, so let me do that. So this module is a capacitive touch module. It has 12 inputs and you can wire them up to whatever you want. I got some copper foil tape that I'm going to be using, but just touching the pins works. The pin on the very end is ground, but I have the next 4 pins set up to mimic the buttons or mirror the buttons. So if I carefully touch this pin here, there we go. You see that it's in the menu now. And if I touch over here, you can see that I can scroll through the menu. It's very difficult to touch just the one pin because I don't have anything hooked up to this, and I accidentally hit back. But anyway, the point is you can get capacitive touch stuff set up and it's being used to mirror the buttons, and I'm super excited about this. So my intent for the capacitive touch is to just have hidden places around the head, you know, like around the back of the neck or around the top area where just a touch will trigger it. I've done some testing. This should work through the materials that I want to be using to construct everything. And if it doesn't work, it doesn't work. But I think it should because I've done some testing. And it worked in my testing, and I'm super excited about this. And I only need 4 of the 12 that it has, so I can do other stuff for the other 8. So I mentioned earlier, which may or may not have made the edit, that I'm only using one camera tonight because my other tripod is in use. When I first started this project, I specifically wanted to try to avoid having to buy a 3D printer because I was like, I don't really have the space for it. I don't want to have to figure it out, yada, yada, yada. That's why I bought this head frame from somebody online who's made a lot of Protogen head frames before. Just didn't want to get a 3D printer. So when this frame arrived and I was trying to figure out how to mount the LEDs to it, there's holes on this, but they don't line up with the mounts on my LED panels. Like, the holes just weren't in the right spot. Looking at the pictures of the listing, it's like, these are the same panels that he's selling. So I don't know what the hell the point of the holes is for, but So I was like, okay, fine. I guess I'm probably gonna need to 3D print some brackets to mount these on here. So I went ahead and bought an Anycubic Cobra, and it is upstairs in the middle of a 17-hour print job right now, and I'm using my GoPro to time-lapse it. And that is why I don't have the tripod for the side camera right now. I got it to make these brackets to be able to mount the stuff to it. I'm actually gonna go ahead and turn everything off so I can unplug and pick this up. So you can see those are where the screw holes are on the head. But if you look at where the mounting points are on the bracket, or the frame that they came on, if it'll focus, you see that they're nowhere near the right spot. And even these other holes that don't have threaded inserts in them aren't quite in the right spot either. So it's like, okay, I'm gonna have to print either something to adapt these screw holes to fit this, or just 3D print something to just replace the frame entirely. And I started printing a lot, well, not a lot, but a good number of test pieces to try to figure out exactly what I needed to do here. This is the first piece that I designed and printed. It's because you can tell because it's in white, which is the color of the filament that the printer came with. It's not the first thing I printed. The first thing I printed was the owl example that it came with on its SD card, and it worked great. So anyway, first thing I designed and printed, cool. Somewhere in here, yeah, this is the matching piece that I designed to try to figure out if I'm doing everything right. So I have a bunch of different holes here that are all slightly different diameters because I was testing my threaded inserts. Holes around here to screw into the tiny little screws on the LED panels. And then the idea would be that you attach this to the LED panel, then you take this and attach this to that, and then you can get the screw holes exactly where you need them. And you know, this mostly worked. It doesn't quite fit together well because I didn't take into account countersinking or stuff like that. And this little screw hole for the LED panel was off a bit and wouldn't screw in. But for a first try, it was solid. Then I made a couple like full size frames that had all the screw holes to mount to the LED panel. This one was the first one, and it was kind of close to the edge here. Then this one was better. I put a little bit of extra plastic so it would fit. And then I think the screw holes are finally in the right spot here. I switched to using 3 smaller screws to connect to the adapter bracket, which was probably this guy right here. I have already removed the threaded inserts because I was running out, and I needed to reuse them. But then one of the problems I was having was this connector. Oops. This connector on the LED panel was running into this vertical support here. So I had to shift the LED panel forward from the holes. Like this is mostly in line, but if you look at these brackets, you can tell, actually more like this, you can tell that they are significantly more offset to move the LED panel further forward to give access, or to provide clearance for that connector in the back. Oh, and I made little test pieces to clip into the back. So there's half holes back here. Like they don't go all the way through. It's a little weird, but they're there and can be clipped onto. So I made little adapters to test where those, you know, fitting for those. And everything fits pretty well. So that was the original idea of the 3D printer, because I'm like, I need to print brackets. Well, then the next problem, or the next thing happened where I believe I mentioned earlier, this broke. And when I got it, it seemed a little bit fragile, so I was trying to be careful with it, but this entire front piece here, where the strings need to mount to, snapped off on both sides here. And then a day or two later, all 3 of these snapped off. And then this piece was just missing entirely, floating around inside the box loose. And I didn't even notice at first because it broke off so cleanly. There were only a couple little tiny overhangs left on the base thing. I was like, what is this piece? I thought it was garbage. So I actually was like, okay, I'm going to use it to test adhesives, and snapped it because I'm like, it doesn't seem like anything. So I had to glue it back together when I realized it went on here. So the glue here is holding fairly well. And I actually have a little piece of toothpick in here to help brace it. However, the rest of these, this already completely broke through again. This broke through, this is almost broke through, and this one's still holding. But this is holding, and this is holding. So I'm gonna have to try to glue this back together again if I want to use this piece. But the first time I glued it together, I made these little brackets. This one, and let me get the one that's not installed right now. Those little brackets here, so they screw into the front, little nubbins on the back to go into those half holes to hold everything into alignment. And they worked wonderfully to hold it in place while I glued it. It's just the glue didn't hold, and by glue, I mean JB Weld epoxy. So like I used something that should hold pretty well. Maybe I didn't do it very well because getting it inside the crack is kind of difficult, especially when it wants to snap apart. So I also tried to use a little bit of super glue to hold it together. So I'm gonna try gluing this back together again later this week. Those worked well for the gluing, but this bracket I have put together here now, oh my God, this is working really well. So what I have over here is probably the final or near final version of the bracket I'm going to use to hold the LED panels in. It's 3 parts. There's the part that actually attaches to the front here, which is similar to the other ones I've shown. It's just a little bit different on spacing and chamfered edges. There's the actual bracket that holds the LED panel in, which has some risers here for PCB support, but they're in the wrong spot on this one. So I'm gonna have to use this on the other side where I don't need them. They're close, 2 of them in the wrong spot. I'm gonna wait until I get the PCBs to get here to validate completely correct that they're right. Anyway, at the back, I have another little screw-on part that just goes on top of the LED panel and goes into those little half holes. And with this in here, this is fucking solid. So I should be able to, once I get this re-glued, I should be able to install the LED panels and use this to just hold it together, and the glue doesn't have to do a whole lot. So this frame should still be functional. I would like to try to get him to send me another one. He said he would if I need one at some point. I just didn't want to worry about it with the holidays coming up. So I'm probably going to ask at some point. Another reason why I want one is when I was test fitting something in it yesterday, the little knobbins were a little bit too big and got stuck in there, and the thing was still not quite cool from printing and broke off. So the pegs were stuck inside there and I could not get them out. I had to drill them out carefully, but that has wrecked the rest of the hole here. It is not the right diameter now because I had to use a bigger drill bit to get everything out. So I would like to get another print of this in this supposedly strong material. I think it was just either a bad print or shipping damage. Probably shipping damage because this piece was just gone. But yeah. And in the meantime, I can use this. And as I mentioned, my printer is in the middle of a 17-hour print. He actually sent me the model for this, and I am trying to print this piece right now on my printer, and it looks like it's working okay. That's not wood. I don't know if there's anything here that's wood. This is particle board. It's the closest thing there is to, is this wood trim? Yeah, there we go. Knock on the wood trim of the front door. So hopefully that finishes correct, prints successfully. It's not going to be done until like 6 a.m. So it's going to have to go several hours unattended, and I will need to get all the supports off of it. But it hopefully will print successfully, and then I can use that instead over here. What I wanted to do before I tried printing that was adjust these screw hole locations so I wouldn't need these damn brackets. I could just screw straight in, but Fusion 3D and FreeCAD were just not having any of it because the thing is a mesh. It's got so many polygons, it can't. I tried converting back to a normal thing to deal with, but it wasn't happening. I spent at least a day or two just trying to get that to work, giving up and just finalizing my little adapter brackets. And the adapter bracket came out wonderfully. It is super fucking solid. So I just need to adjust the positioning of these 2 supports and possibly this one a little bit as well. But then it's just going to be great. So this is a printout of the PCB just on cardstock, and I cut out where this connector is to give it a place to center. This hole is going to be there for the power for the LED. Then I cut out the screw holes that I would put in. Clears the bracket at the back quite well, or by a lot. The tolerances there could be a lot closer. But the problem is somehow I goofed the mirrors up on this frame because I designed it for the other side. I designed the right side of the frame, but I needed the left side to have the PCB support. But I somehow goofed measuring and mirroring for some of these supports, so this one and this one are swapped vertically. The other 2 look like they're pretty close, but I'm just going to wait until I get the actual PCBs here to know for sure, is this stuff in the right spot. And I have some nylon screws. I have some nylon standoffs with nuts. So I can go to all of these little holes here for all these little daughter boards and secure them because they all have little holes here on the bottom. Whatever. I can secure all these little breakout boards and not just rely on the pins to hold them in place. The PCBs should get here next Tuesday. It's Monday right now, but the PCBs should get here on Tuesday. I'm going to spend the rest of this week working on the physical part of the frame, touching up the paint, figuring out how to cut the foam, gluing up the surface that I'm going to be putting on it, and yeah, it's going to be a busy week, but I'm looking forward to it. The software is acceptably done. I don't have to do anything else to the software if I don't want to, except adjust the positioning of stuff and the sizes of the graphics it uses. Everything else is just putting it all together, and I'm super excited.
Okay, hi, it's the next day. I just finished editing the rest of the video. Figured I'd show you around the PCB a little bit, as well as the actual 3D models of those brackets that I was using, just to make it a little more clear of what's going on. Let's actually start on the schematic view. This has got everything on it. It's relatively straightforward going on here. We have the main matrix portal board, the input and outputs from the LED panels. We have the OLED display over here on its own connector. We have the GPIO expansion chip, which is mounted directly on the PCB, not using a breakout because I was able to get those chips pretty cheaply. From that, it goes to the buttons. I have 2 extra buttons on here that I'm probably not going to use, but I figured I'd put them on there just in case I do. There's an external connector for all of the buttons in case I want to put physical buttons somewhere else. This is the clock breakout, and the clock is going to be connected, as I mentioned, directly to the matrix portal with the little I2C cable. So the only thing that this needs on this connector is the I2C bus to send elsewhere. I have the microphone here, and this is what I did dumb. I thought that it had a wire to connect directly to the matrix portal, but it doesn't. So I needed to either route the signal from this other extra pin that I'm not using down to here, or put a header on here to plug that cable into. And I didn't, so whatever. I can just bodge wire to make it work, but it's fine. It has gain adjustment on here with both a physical jumper you can move and a solder pad once you know what you want it to be permanently. I have a connector here for a serial connection to an OpenMV camera module for eye tracking. I haven't quite gotten that working yet, but I decided to shelve it until I got everything else done. But I still left provisions for it on here. It just needs 2 serial lines and a ground. I'm probably not going to power it from this, so it's not going to be powered by default. But if you do need the 3 volts there, you can. There are 4 pins on the matrix portal that I am not using yet. 3 of them are on the Hub 75 connector that's on the matrix portal, which means they're output only, and 1 of them is a normal pin on the side, and I'm probably going to end up using that pin for the microphone for now. But since those aren't being used for anything, I put it on a header with a ground and a power, so if there's any reason to need them for anything, they're there. The capacitive touch breakouts over here, and also giving another set of headers to connect to it just to try to make it a little bit easier and make it more secure because it doesn't have mount points on the bottom. It only has pins on the bottom. That's basically the schematic. It's pretty straightforward. If we can look at the circuit board itself. So this part is similar to the first version. I just fixed the alignment issues on some of this and rotated this return feed and moved the buttons around and added more. So up here's the chip for the GPIO breakout, some passives to support it. The clock's going to be here. The microphone's going to be here. 4 buttons here. These buttons I'm not going to populate. I'm probably not going to populate this header strip unless I need to either. The OLED display is over here. Capacitive touch is down here. And here's the OpenMV breakout. And some of this stuff I'm not going to populate because I don't need it right away, but I wanted to have it in here. The board is incredibly clean. I'm very pleased with how it came out. There's some routing that's a little bit weird. just having to go roundabout to not cross over other paths, but there are no vias, and there's like a dozen or so signals on the back side of the board. Everything else is on the front. So the majority of the back of the board is just a ground plane. This is one ground plane except over here. So this very edge of the board is not directly connected to the rest of the ground plane. It is connected through a trace on the front. Everything else is just a single solid ground plane, which is lovely. Yeah, hopefully these will be here in about a week. They're already about halfway through processing at PCB Way, so maybe they'll ship a little bit early and I might get them Monday instead of Tuesday. I don't know. We'll find out. I'm excited. I also put a bunch of labels on the back just for what all of the pins are. I think I figured out why KiCad was so crashy for me. It doesn't like it when the windows were last open on my second monitor, and that's what I've been doing for recording since that's a not super widescreen monitor. I had no problems with KiCad crashing when I was doing this work because I was doing it all on my main monitor. But anyway, here's a 3D render of what the board looks like. Obviously, it doesn't know how to render the breakout boards because it just doesn't have those. But everything else here is on here. You can see all of the silk screen. If we rotate to the back, you can see the silk screen back here and the other connector. And yeah, so that's the PCB. The other thing we can do here is look at mounting bracket that I have. So this is 3 separate parts, as I mentioned. We have the actual bracket that connects directly to the LED panels with these tiny little screws here, 6 of them. These 3 holes are to connect to the frame bracket that goes to the inner head frame, which has 2 screw holes at the locations that has. And then back here, these 3 holes connect to this rear cover, which goes around the vertical support at the back of the head frame and into those little half holes to hold it all in place. And everything is incredibly well fit together here. It's very well designed, other than a few of these in the wrong spot somehow. I'm not entirely sure how I goofed that. I'm going to wait until I get the PCB so I can hold it up to the one that I have printed, figure out exactly how far offset they are and what directions, and make the adjustment and print the new ones, and everything will be hunky-dory. As I showed in text earlier, that print failed. That's really unfortunate. I might try again in a couple of days once I get more filament because I don't know if I have enough left. And also I'm going to try to switch to using Octoprint instead of just the interface on the printer. I have stuff arriving to be able to do that tomorrow. So I might be trying to print again on Thursday, and I'll rotate it to fit better into the bed because my printer's bed is not that big. It barely fits. Today was mostly a wash of getting stuff done because I cut my finger on the bed on the printer this morning. So I have a Band-Aid on my finger right now, which is just getting in the way of typing and definitely would get in the way of doing other constructive stuff. So hopefully this heals up enough by Thursday to start doing more heavy construction. Tomorrow, which is Wednesday, is my last good weather day until Sunday. So I need to run to the store and get paintbrushes because I can't find any, and then do the touch-up painting on the main part of the head frame tomorrow, and then Thursday start figuring out how to cut the foam and glue stuff, I guess. Hopefully my finger will be healed up enough by then. Sunday, do the glossy top coat on the head once the weather's good. Friday and Saturday, more just working on other stuff that goes onto this head frame. I can't permanently attach anything until I get the top coat on it, unfortunately, but I can at least measure and cut and dry fit stuff. So today, while my finger's been injured, I've not been wasting time. I've been moving on to trying to figure out how I'm going to attach the elastic strap that goes around the back of the head, of my head, to hold the head onto my head. Measured and printed a couple of little test brackets to just fit into the circular holes that are on the head frame to just kind of slide into, and then eventually build them out to like strap sliders so you can weave the strap through it and pull it tight. I got a little bit of work done on that today, and I'm going to continue on that as needed if my finger is still too injured to let me do the physical construction stuff. That's the current status of my project. I apologize for the lack of updates the last couple of weeks. As I mentioned, it's just been a crazy IRL stuff. I'm going to be recording a bunch of the process of doing this work, but I'm going to not try to let it get in the way of getting the work done. So it might not be great camera positioning, what have you. And I'm probably not going to edit until I'm done, just to take advantage as much as possible of the 5-6 days that I have off before I have to start going back to work again. If you've enjoyed this video and the series, please hit the like button, subscribe, leave a comment, whatever. Until next time, thanks for watching.